Endeavour Houston, good config for the burn.
Good config for the burn. Thanks, Nick.
Test 1, 2, test test.
Houston Endeavour, just a heads up, we're going to turn off a couple of MDUs that we don't need.
Copy, Roman. Thanks for the heads up. Roman will take auto on the DAP and an item 27, please.
You got it.
Endeavour Houston, good burn, no trim required.
We copy, thanks.
Roman will take the gimbal trim as written and no deltas on page 5-2.
We copy. Here come the gimbal trims and no deltas. Houston Endeavour, here comes Ops 106.
Thanks, Roman. We're watching.
Houston Endeavour, we're picking up in post-insertion page 1-3, and when we get to block 1, do you have any deltas?
Roman, you're tagged up right with us. In block 1, we're going to single G2.
Copy, single G2 in block 1.
And Roman, while I've got you, we're looking at a preliminary TIG of 3:35 for the NC1 burn.
335, thanks.
This is Mission Control Houston, now 46 minutes into the flight of the Space Shuttle Endeavour for the STS-127 mission. And the team here in the Space Shuttle Flight Control Room here at the Johnson Space Center is watching over systems on Endeavour and helping the crew go through the procedures to set up for the operations of Endeavour in space, transitioning the vehicle from its ascent phase to the orbit operations. One of those first operations was a firing of the orbital maneuvering system engines. Both engines were used to change the orbit of Endeavour to more circularize that. It was a 96 foot per second burn for a little more than 1 minute that occurred about 5:41 p.m. Central Time. And here on NASA television, we're expecting the post-launch news conference in about 10 minutes. That will originate from the NASA Kennedy Space Center. The participants include Bill Gerstenmaier, the Associate Administrator for Space Operations, Steve McLean, the Canadian Space Agency President, Kuniaki Shiraki, the Japan Aerospace Exploration Agency Executive Director of Human Space Systems and Utilization,
Step 1 of block 1.
Mike Moses, the Shuttle Launch Integration Manager, and Pete Nikolenko, the STS-127 Shuttle Launch Director.
Good inbat. We're ready for 106.
Houston Endeavour from the mid deck. I'm putting block 5 and 6 in work.
Copy, blocks 5 and 6, thanks.
Houston Endeavour, step 4 of block 1. We've got a single G2 NBAT. If you concur, we'll transition to Ops 2.
Endeavour, your go for Ops 2.
Houston Endeavour, putting block 2 in work.
Copy, block 2, thanks, Tim.
Houston Endeavour, block 1, step 6. We're ready to take the SM machine to Ops 2.
Roman, we're ready for it, thanks.
This is Mission Control Houston. Here in NASA Television, we'll be standing by for the post-launch news conference from the Kennedy Space Center. That may be delayed a few moments. It was scheduled to start at the top of the hour here. Here at the Johnson Space Center, the team here in the Space Shuttle Flight Control Room is continuing to work through the steps with the crew on board the Space Shuttle Endeavour to set up for the orbit operations. The onboard computers have been changed to the Ops 201 mode, that is for the on-orbit operations. And Flight Director Brian Lenny pulled the team here to prepare for the payload bay door opening, which is scheduled for about 6:28 p.m. Central Time, and the team is ready to support that. This is Mission Control Houston. While we're standing by for the post-launch news conference at the Kennedy Space Center, we do have some launch replays that will air momentarily.
Endeavour Houston for step 10 in block 1. We see you working about the top 2/3 of the step. And when you get there, you're go for the air log resets.
Houston Endeavour, I think we had a quick handover. I missed your last.
Sorry about that, Roman. In step 10, we see you working about the top 2/3 of the step and also the switch guard step at the bottom. And when you get there, you go for the air log resets.
Okay, thanks, X. We'll we're just about to pick up in the if no fail GPC, and we'll work that one if the single G2, the airlog resets, and the switch cards.
Good copy, Roman. Thanks very much.
Houston Endeavour, Block 2 is complete.
We copy, Tim. Block 2 complete. Thanks very much.
Houston Endeavour and post insertion, if you double check us, I believe Block 1 is complete.
Roman, we concur. Great job. Block 1 complete. Thank you very much.
Houston Endeavour, we're putting blocks 3 and 4 in work.
Copy, 3 and 4, thanks.
And Houston Endeavour for Inco.
Go ahead for Inco.
Just want to make sure they have commanded sync.
You're in a good config.
Copy, good config. And Houston, we are ready to maneuver to the payload bay door opening attitude.
From them we see a good load and a good DAP. We're ready to maneuver.
Copy, here comes the maneuver.
Endeavour Houston for Roman, when you get there, we'll be ready for RAD Act as written.
We copy, thanks. Houston Endeavour for tag up. Block 4 is complete.
Copy, block 4 complete. Thanks for the tag up.
This is Mission Control Houston. We're now ready to go to the post-launch news conference at the Kennedy Space Center, coming up here momentarily on NASA television.
Houston Endeavour, Block 7 complete.
Good evening and welcome to the post-launch news conference for Space Shuttle Endeavour's STS-127 mission to the National Space Station. Joining us here today to discuss the launch is Associate Administrator for Space Operations, Bill Gerstenmaier. Canadian Space Agency President, Steve McLean. Japan Aerospace Exploration Agency Executive Director of Human Space Systems and Utilization, Dr. Kuniaki Shiraki. Shuttle Launch Integration Manager, Mike Moses.
Good evening.
And STS-127 Shuttle Launch Director, Pete Nikolenko.
Good evening.
We'll start with opening comments from our panelists and then take your questions. Mr. Gerstenmaier.
Thanks, John. It's great to be here. It took a lot of patience and perseverance to get here, but the launch team did a great job of staying focused and continuing to move forward and understanding what we needed to do to get ready to go fly. The teams in Houston did a great job of staying ready and getting prepared to go execute this very demanding mission that's coming up. So again, it's a tribute to the team. We had a great launch today. We were ready. The weather finally cooperated, and we had just an awesome launch today. Again, I will caution you that the mission is very challenging in front of us. The 5 EVAs, the robotic activities will take the absolute best that the teams have, both in Houston and in orbit. The teams are fully prepared. They're ready to go do what they need to go do, and we look forward to the exciting activities as we install the exposed facility out on the Kibo module. I think you'll also see in the ascent video that we had some foam loss events. You'll see those. There's several losses that occurred. There were probably a couple orbiter hits prior to the aerodynamic sensitive transportation time. That's the time when we could potentially get damage to the shuttle. There are probably 2 or 3 hits that you'll see in the video. You can clearly see on the front part of the orbiter some white indications where the tiles were dinged. We don't consider those an issue for us. Those are probably coating losses. The issues will be in the back of the vehicle, and we'll take a look at those when we do the roll pitch maneuver that's planned. We'll also get wing leading edge sensor data. So all the tools we've got in place for foam loss and understanding what occurred will be in place, and we'll go look at those through ascent. So again, you'll see that when you look at the video. It shouldn't surprise you. We had very good lighting today, so we probably saw the tank much better than we have on several of the past flights when they were evening launches. So with that, I'll turn it over to Steve for any remarks he has.
Yeah, I'll keep my remarks fairly brief. First, I would like to congratulate NASA. I think turning around the lightning strike and learning how to cooperate with the weather is very impressive to watch. I'd like to congratulate JAXA as well. This is an exciting mission for them. as it is for us. And since Marc Garneau flew in 1984, this is our 15th mission in 25 years. And I think we feel very privileged to be a partner in both the shuttle program and the station program. And when you consider that we have 5 partners up there right now, when Bob Thirsk welcomes Julia Payette in 3 days at the International Space Station, for Canada, it doesn't get any better. And we've had an outstanding partnership with NASA over the last 20, actually 50 years now. And what I like about this mission is we will be using Canadian technology every single day, and I hope that partnership continues in the future, and I hope Canadian technology continues to be used in the future. And I'll just close with, I've seen many, many launches, and I am very impressed with how unique each launch is in terms of watching it. Okay.
Today is an exciting and historic day for JAXA. The Space Station Endeavour, Space Shuttle Endeavour with the keyboard's last element was launched successfully here at the Kennedy Space Center. It was injected into the planned orbit, and I feel great pleasure for this successful launch. The assembly of all the keyboard elements will be completed during this 16 days mission. In addition, astronaut Koichi Wakata, the first Japanese expedition crew, who has stayed there on board ISS for 4 months, will participate in completing the assembly of keyboard elements and experiments. There are a lot of assembly activities in his mission. For astronaut Koichi, the job to complete his mission will bring glory to the end of his long-term stay. I have a confidence that he will accomplish this hard job with his hard training and professional skills, I believe. I sincerely appreciate the support and cooperation from NASA and other international partners who have been working with us. I wish success for the STS-127 Endeavour mission and the safe return of all the crew. Thank you.
Let's see, folks, on the way over here, I was trying to think, what's that soundbite I'll give you at the beginning, and I said, okay, it's worth the wait. But the truth is, no, I'd much rather do this without the wait. It was a really tough road to get here. If you go back, this started for the OV-105 team way back in October, when we rolled out for the initial launch on need for the Hubble launch that was back there in that month. And then we had some delays with Hubble, and everything just started sliding, and the 105 team slid right along with it and found themselves right back in the launch on need posture here in May when we launched 125. And then we got them over to the right pad A, and we started working the flow, and then they had their own challenges. We had a lot of weather issues while they were sitting out there on the pad, and then we got into the launch counts. We had the GUP leaks that we've overcome on the ET vent. We had our own lightning strikes right before launch that we had to work through. The teams did a great job. If you compare back to what we did on STS-115 when we had a lightning strike close to final count, that took us 3 or 4 days to get through. We were through with this one in less than 2 days and knew we had a clean vehicle for launch. And then just most recently, just the challenges of Florida weather in the afternoon to get both range weather for launch and RTLS weather for abort landings to line up with us. We fortunately didn't have to talk about TAL weather today. That's yet another thing we could have had. So I guess the 105 team was a little lucky. The Europe supported them. But basically, with all that said, it was an unbelievably smooth countdown today. And for that matter, every countdown that we were in recently here has been unbelievably smooth. The team was flawless. The vehicle was flawless. The ground systems were flawless. Everything just went great. I talked to the folks back in Mission Control. They finished up OMS 2. Everything was fine. You might have heard a call during ascent to turn on high-load duct heaters. AB, those are actually a set of heaters to beef up some of the heaters in the FES, which is the flash evaporator system. We use that to cool the shuttle. It was just they saw a little more cooling than normal, probably a little bit of water in there that we weren't expecting, although with the rain you probably could expect it. And so that heater came right on and the system stayed within parameters. There's no issues with the FES. So just one extra switch throw for the crew going uphill. Bill Gersmeyer talked to you about some of the foam releases we saw, and the teams, that's a normal plan for us. We bring out all our assets and our tools. We'll do the RPM, we'll do radar wing leading edge downlinks. We have the radar imagery that we'll see, all the ascent photography that we just took. The crew handheld photography, the tank will show us a lot what came off the tank from both the crew handheld and the ET digital umbilical wells. We have the Flight Day 2 inspections where we pull the OBSS out and look at the wing leading edge. So the bottom line is, we saw some stuff that some of it doesn't concern us, some of it you just can't really speculate on right now, but we have the tools in front of us and the processes in front of us to go clear this vehicle for entry, and all that will be followed. And you'll know, as we know,
what we find as we do that stuff. So no real worries there. We just got to wait and see what happens. You also might have heard we had last night a fuel cell test that we ran. We were a little worried at low power levels. Fuel cell 3 had a condenser exit temperature that was a little higher than we thought. And when we hook up to the space station, we drop the power levels in those fuel cells because we start taking the power from the station instead. And so at that low power level, we wanted to make sure we could still remove enough water so that we didn't cause problems for that fuel cell's performance. And the way we would have fixed that would have been to put more load on it, which basically meant we wouldn't have been taking as much power from the station as we thought. So the real concern there wasn't from a hardware issue with the fuel cell itself. It was more from a mission planning standpoint to make sure we really understood the calculations we were using to predict cryo usage. So we asked the team here at KSC to dial it down a little bit so we could see how it performed at lower power levels. We got really good data. The teams factored that into their calculations, and they showed that we're plenty fine on margin for the on-orbit mission. They'll probably talk a little bit more about it. They'll watch, see how it really performs once we do hook it up. So you might hear us talk a little bit more about it, but I don't expect the fuel cell problem to be any kind of problem on orbit whatsoever. Let's see. With that, I guess, I can switch gears to orbit. Like Bill was saying, this is a very challenging mission. It's very packed. We made some changes to be able to launch today. If you recall, we had what we cut out that said that today was not a good day to launch based on a progress docking that's coming up. So the way we did that is we kept undocking on the same day. So from the progress standpoint, we're still leaving space station at the same time. And we did that by moving some activities to the other side of undock, most notably OBSS handover. The very last thing we were going to do before we undocked was pull the OBSS out of the bay with the space station arm, hand it off to the shuttle arm, and position it in a position that then the next day we could undock. After that undocking, we would then get that arm and immediately start our late inspections. We do that for two reasons. One is it's a good get-ahead to do while you're docked because you have extra sets of hands and extra cameras. The other thing is if you're going to try to undock in the morning and complete all your late inspections in the afternoon, you need to have had the arm already being held by the shuttle arm. There's not enough time in the day to get it out with the shuttle arm and fit that all in with an undocking in the morning. So what we did is we just flip-flopped. We moved undocking to the night before, and we gave the time that we were going to be undocking to OBSS, undock, and hand off from the shuttle arm itself. So really we just flip-flopped two activities. A couple other things, minor, but that was the big time saver. And so that leaves our full docked mission, that leaves our full orbit mission. The dock mission stays 1 day shorter, and the undock mission now gets 1 day longer. So we keep the same 16-day mission. We undock on the 28th, the same day that we had been planning to, and that's how we were able to overcome our timeline challenge and have today as a good launch day. So with that, I'll just wrap it up by saying, before we introduce Pete here, I wanted to congratulate him. You'll notice his tie's cut off. This was his first launch, and I can't think of a more challenging first flow for a launch director. Pete did an outstanding team leading the job. I am unbelievably impressed with his ability. So I'll say thanks to him for getting us here.
Well, thanks, Mike. Since the last time we met a couple of days ago, we had a really smooth 48-hour launch countdown scrub turnaround. As many of you may know, we did bring the rotating service structure back around. We replaced those thruster Tyvek covers, all of them, and then basically reset the clocks, if you will, with replenishing liquid hydrogen and oxygen to get ourselves in posture to launch today. And as Mike did say, we had an incredibly smooth launch countdown today. Again, a smooth tanking. The ground umbilical carrier plate had no leaks again. And about the only things that we did note coming in through the course of the day, the final inspection team did note some of that liquid hydrogen T0 umbilical slushy ice, if you will, just as we had seen the previous two tankings, but the dimensions of that slush was bounded by what we had already noted over the previous couple of days, so that was no issue. And then later on in the afternoon, there was a facility interface controllers inside the pad terminal connection room that had dropped out a couple of measurements, but we knew we had alternate measurements there, so that was no issue. So by and large, the operations and the technical team was right on the mark, and there are no issues. Weather, again, was another one of those challenges for us. We did have some afternoon thunderstorms that were popped up as a result of the sea breeze that had developed. And then later on in the late afternoon, we ended up having to watch some anvil clouds over the ocean to see whether or not they were going to develop and cause a threat for us. Unfortunately, they dissipated, and the weather did finally, in fact, cooperate. So it all turned out really good for us over the course of the last hour. Finally, it was just a really smooth launch countdown, a great terminal launch, and an outstanding launch. And really, I think it was an interesting, it was a testimony for this entire launch and the flight control team. You know, it was an outstanding effort, and they made the complex look really easy. So, and it really was a case of persistence. So it was I'd like to congratulate the entire team for an excellent launch. Thank you.
Thanks. We'll now take questions here at Kennedy Space Center. Remember to wait for the microphone, state your full name and affiliation. Why don't we just go in order here?
Hello, Mark Kirkman, Interspace News. This is for Mike Moses. I know you said you're comfortable with it, but just a couple part question on the fuel cell. It's my understanding that when you get docked that you'll be either below the flight rule limit for percentage on KOH or just above it. And I was just wondering how you plan to deal with that. And can you clarify for me the worst case scenario if you did go down the fuel cell, what does MDF mean for this particular mission? What would you get accomplished with an MDF flight?
Let's see, the KOH calculation we do in orbit is a calculation based on a bunch of inputs. One of those inputs is the condenser exit temperature, which is the parameter we saw running a little hot. And so that part of the test results were to see what the actual KOH concentrations were, measure the pH in the lines down here, and see how things were performing, to kind of calibrate what we saw on the ground with what we're going to calculate we see in orbit. So that's kind of what that test was for. There's a lot of other parameters that lead into the main concern with that fuel cell is flooding it, which is putting too much water